last time we saw that each program in Linux can output something on some information or some data on the screen, and this is called standard output. It can also output some error messages, and these are sent to a separate channel, which is called STDR, standard error. And actually, it is linked to the screen as well. So error messages by default are sent to the screen. And if a program needs to get some input, it gets it from standard input, which is by default the keyboard. But we also see that it is possible to redirect standard output, standard error, and standard input. For example, to redirect the output of a program to a file, we use the redirection operator greater than, and then the file name. It will send output to the given file. Actually, if we want to append to the content to the existing content of the file, then we use this double greater sign. So this is appending to the existing content of a file. And to redirect the standard error or error messages to a file, then we use this operator. But actually, if we want to append to the existing content of a file, then we use a double greater error message and greater message sign. And it is also possible to redirect the standard input so that the program does not read the input from the keyboard, but it gets the input from a file. And we can do this redirection with this operator, reading from a file. For example, the program cut, if we don't give any arguments to this command, it will read from the standard input and it will output to the standard output. But now I'm redirecting the standard output of the command cut to a file. Now, everything that I type from the keyboard, from the input, the command cut will send to this file, because the standard output has been redirected to this file. And I press Control D to signal the end of input. And now if I check the content of file test1.txt, it is this line that I type. And I'm giving this file as an argument to the command cut, but I can also use redirection like this. In this case, the command cut is not reading from the keyboard, but is reading from the content of this file. This is what this means. So it is the same thing as typing the content of this file on the keyboard. And the command cut, actually, whatever it reads from the standard input, it is going to send it to the standard output, to the screen. So it is sending it to the screen. And then we saw also the pipe operator. And the pipe operator takes one command on the left and one command on the right. And the output of the command on the left is going to be sent or to be piped as input to the command on the right. And we can we can actually chain several pipe commands, and we can chain several commands through the pipe operator. And let's see an example. For example, this command lsbin is going to list the content of this file, of this directory. Now I am listing the content of these two directories, but the content is very long. And if I want to see it screen by screen, then I can send the output of command ls to the command less, and less is going to display it page by page. I type Q to exit from less, and I can sort the output of the command ls and then send it to less. And we see that some lines have duplications. They are duplicated. It is because the same command is listed on both directories, both on the directory /bin and the directory /userbin. And we can use the command wc with the option -l to count the number of lines on the input. And so there are a total of 4,101 lines in both of these two directories. But if we use the command unique, actually it is going to list on it is going to remove the duplications. For example, if there are these two lines, then it is going to remove one of them, and it is going to keep only one. Or if there are more than one lines, then it is going to keep only one of these lines. And so after counting them with WCL, we see that the number of lines that is outputted is smaller than in the previous case. So we see that the duplications have been removed. And actually, if we add the option -d to the unique command, then in this case, it is going to show only the duplicated lines. If there is a line that is not duplicated, that is a single line, then it is going to be removed. And how many duplications we have, we can count with the command . So there are these many duplications and this many unique without duplication, unique lines. We can also use the command grep, and grep is used to search for a word or for a pattern, and it is going to display the lines that contain this word. For example, if I search for the word zip, then it is going to list all the lines that contain this word zip. And let's count how many of them there are. There are 19 lines that contain the word zip. And the command grep actually with the option -v does the reverse. It shows only the lines that do not contain the word zip. So in this case, actually, there are a lot of lines. We can count them. There are many lines that do not contain the word zip, but there are only there are only 19 lines that contain the word zip. So with -v, the command grep does the opposite. It shows only the lines that do not contain this word. Without the option -v, it shows only the lines that contain this word, zip. Now let's see the commands head and tail. First of all, let's create a test file. Let us check the content of this file. Now, if I type the command head, it is going to show the top 10 lines from this file. So this is a long file. It has many lines, but with the command head, we get only the first 10 lines. And with the command tail, we get only the last 10 lines from this file. And the command head and tail can also take as argument the number of lines that should be displayed. For example, if I say head -n5, number of lines that will be displayed is 5. Only the 5 top lines will be displayed. And the same with tail. And actually, it is also possible to say just -5, and it will do the same. It will display the 5 top lines, and tail -5, it will display the last 5 lines from this file. And the command tail usually is used to check the log files of the system. Let me see if I can access some log files. Log files are usually on var log on this directory. So log files are messages from different processes on the system, or from different applications on the system. For example, this mail.log is from the mail program. And this bootstrap.log is the messages that are displayed by the system when it starts up. And this dpkg.log is the messages displayed by the package management program. And this syslog is a general log system that is used by many programs. Let's check, for example, the last lines of this syslog. Permission denied. Let me try with sudo. Okay, these are the system messages displayed by different parts of the system or different applications of the system. And I can also add this option -f. -f means follow. And now the tail command will not finish immediately, but it will keep displaying. And if some new messages are added to the system, then it will display them immediately. Right now, there are no new messages. That's why we don't see anything. And let's cancel it with Control C. Control C. So with this option -f, we can follow the messages from the content of a file as it changes in real time. And this is useful to check the log messages of a system. Let's check the log messages of package system. Oh, it is empty. What about Bootstrap? What if we follow it? Actually, there are no changes right now because nothing. The setup. These messages are displayed usually while the system is starting up. And another command that can be used with a pipe is the command T. It is like this one because it sends the input that it gets to two different directions. One direction is to standard output, and the other direction is to a file, one or more files. Let's see how it works. For example, the command ls user bin, we can pipe it to the command t, and then to the file ls.txt, and also to the command grep zip. So the output from this command is sent to the command T, and the command T sends it to two different directions. One is to the standard output, and from the standard output through the pipe we send it to the command grep zip, and the other direction is to the given file. So it will split the input into different directions, or it will duplicate it. So we get the output from this command. The command T is sending into standard output, and we get this output on the screen. But we can check the command. We can check the file ls.txt, and we see that it actually has the command, the output of the command ls. It has the output from this command has been stored on this file as well. Now we will start with another topic, which is the way that Bash interprets the commands that we give. When we type some command to the prompt, for example, one of the commands is echo the shell, Bash in this case, gets this and splits it according to the spaces, to the white spaces. The first word is considered as the program which needs to be executed, and then the other parts are passed as argument to this program. So Bash takes this input, splits it according to the spaces. So bash is taking the first word and executes this program, and then to this program it is passing these 4 arguments. So in this case, there are 4 arguments that are passed to the command echo. But what the command echo does is just it sends to the standard output, sends to the terminal all the arguments that are passed to it. So the result is that we just get these 4 arguments displayed in the screen. And actually, echo separates the arguments by a space. When it sends them to the screen, it separates them by a space and also appends a new line character. So we are getting to the next line. So this is what echo does. Now, if we type, for example, this command, the output is the same. The output does not change. Why? Because this is a space again, and so it is used as a separator between the arguments. And so we still have the command echo, and this command echo is taking 4 arguments again, and the command echo just displays the arguments that it is taking, and this is the result. The 4 arguments separated by a space and with a new line character at the end. So that's why these many spaces don't make a change. But let's see something else. For example, let's change the directory to the directory user /user. Now, if I type echo star, now what is happening right now? What is the thing that is happening is that bash is reading this command, and then this star is considered a wildcard. A wildcard is replaced with something else, and it is replaced actually with all the files in the current directory that match this wildcard pattern. And star actually matches everything. So it is matching all the content of this directory. So this command echo star is actually the same as typing echo and all the matching files. So it is the same as typing this one, because the star is replaced by the shell with these files and directories that match the pattern, that match the star. And so the result is that all of these, the names of all the files and the directories are displayed by the command echo. Now let's try another pattern. For example, echo lib star. Again, shell is treating this as a pattern, and it is trying to match the content of the current directory with this pattern. And this star matches anything, but this lib matches only lib. So it is going to match all the files that start with lib. So it is starting with lib and then anything. So actually it is listing only lib, lib64, libexec. And notice that this star also matches an empty string. So the pattern lib star matches lib as well, matches this one, lib as well, because star can also be an empty string. And of course, it also matches lib64 and libexec. Or if we try, for example, echo star bin. In this case, it will match all the files or directories that end with bin. And actually, we have only bin. And again, we see that star is matching, can match an empty string at the beginning. and also sbean. So this command echo star bean is the same as typing echo bean sbean, because this is replaced by the shell before sending the arguments to the command echo. And the command echo actually gets these two arguments from the shell. Let's try some more patterns. Echo lib star 32. Echo lib star 64. Now, in this case, libstar 64, it is finding a directory that matches it, and it is displaying the directory that is matching the pattern. But for the case of libstar32, there is no directory that matches this pattern, or no file that matches this pattern. So since shell is not able to replace to find a match for this pattern, it is sending it as an argument to the command echo, and the command echo is printing the pattern itself in this case. Okay, it is matching this shell in this case. Now this /star and then /bin, it is matching the directory /user/local/bin. This is the only directory that matches this pattern. Or only this path is matching this pattern. Only this path is matching this pattern. Now, besides star, we have also this wildcard question mark. Question mark can match only one character. So star matches any characters, any number of characters, even 0 characters. But the question mark can match only one character. For example, if we say echo lib, we get this match, lib, and 2 other characters. It is only lib 64 that can match this pattern. And if we say lib and 3 characters, there is no file here that matches this lib and 3 characters, because here we have 4 characters. So if nothing matches this pattern, then the pattern itself is sent as an argument to echo, and echo is displaying it. But if we say lib and 4 more characters, then it is matching this lib exec here. Now let's try this pattern. Echo, or first let's list again the content. Echo lib and then a question mark. Now this question mark can match any character, But here in these square brackets, we have a list of characters. So it can match any, it can be any of these characters. But it matches only one character. So this part of the pattern is matching 6 because 6 is in this list. And then the question mark is matching any character, so it is matching the number 4. Let's try, for example, this. Nothing matches this pattern, but we can say echo lib, and it is going to match this lib64 because this is a range. 1 minus 9 is a range of characters, and it is the same as typing all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So in short, we type it like this: 1 minus 9. It is a range of characters. So this will match any number from 1 to 9, and this again will match any number from 1 to 9, and overall this pattern is matching this lib64. Or we can say, for example, so this will match any number from 1 to 9, and this will match anything that is different from 2. So again, 4 is different from 2, and it is going to match 4. Or we can use character classes instead of saying 1 minus 9. We can use this character class digit. So this square bracket semicolon digit semicolon and then closing square bracket, this is called a character class, and it is going to match any digit from 0 to 9. So let me remove these extra spaces, and so again this is matching the 4, the second 4, the second number here. And we can match, for example, alphanumeric numbers. So there is a character class for alphanumeric numbers, and it is called alnum. So we start with li, and then any alphanumeric number, and then any digit, and then any digit again. So it still matches. And actually, there is a character class only for the alphabetic characters. So this class is alphabetic characters, so it is going to match I, and this is an alphanumeric character. Alphanumeric characters are all the letters of alphabet and all the digits from 0 to 9. So this alpha is smaller than alnum, because alnum alphanumeric contains the digits as well, and this contains only the digits. So actually, alphanumeric class is the same as alpha plus digit. If we make the union of these two, then we get alphanumeric characters. And there are other character classes as well. For example, for matching only the uppercase letters. Let's see this example. Echo etc. And then upper. This matches only uppercase numbers, and then star, anything. So actually, what we are displaying here, or what we are outputting, are all the files that start with an uppercase letter in the directory /etc. So we get etc /modem manager, etc network manager, etc package kit, etc upower, etc. All of them start with an uppercase letter. There is also this tilde that can be used like a wildcard by the shell. So it is always replaced by the shell with the home directory. We have seen it before with the command cd, and it sends us to the home directory. But we can try it with the command echo tilde, and we see that tilde by the shell is replaced with the home directory of the current user. And actually, if we want to get the home directory of another user, then we have to type the user ID after the tilde. And, or for example, Andrew, it is going to, the shell is going to replace this with the home directory of Andrew, of another user, or Dashamir, for example. There is a user with username Dashamir at home. This one. Now let's see some arithmetic extensions. For arithmetic extensions, we type dollar and then this double parentheses. And then inside we can write an arithmetic expression. For example, the empty spaces do not matter, so we can remove the empty spaces and we still get the same result. So what is happening in this case is that the shell is replacing this one with the value of the arithmetic expression. So it is getting the arithmetic expression inside the parentheses, and it is evaluating it, and it is replacing the whole expression with the value of the arithmetic expression inside it. And this can be this expansion can be recursive. For example, we can have another arithmetic expansion inside. For example, 5 to the power 2. This double stars is for the power. A single star is multiplication, and double stars is power. So this is 5 to the power of 2, or 5 square. 5 square, and then let's multiply it by 3, for example. 5 squared is 25, multiplied by 3 is 75. So first it is going to make this expansion, and will replace this one with the result, which is 25. And then it is going to make, to apply this expansion, and will replace it with the result, which is 75. And then it is going to call, the shell is going to call the command echo with the argument 75, and the command echo will display it on the screen. And for the division, divided by 2, and the result is 2. Why do we get such a result? Because this is an arithmetic division, so it is giving the result without a remainder. It is not an exact division, it is an arithmetic division. And if we want to get the remainder, then we can use this operator. So 5, the remainder of 5 divided by 2. This is the remainder of 5 divided by 2. This is the result of the integer result of 5 divided by 2. Or 7 divided by 2, it is the same remainder. Or 8 divided by 2, now the remainder is 0. Now let's see brace expansions. So brace are these curly braces or curly brackets, and this brace expansion works like this. We have something, let's say that we have something here on the front, and then we have a list of options here, for example, and then something on the back. And what is going to happen? What is going to happen is that this will be expanded such that we get front, the first option, and then back. And then we get again front, the second option, and then back. And then we get front, the third option, and then back. So the command echo in this case is going to take these 3 arguments. And this expansion is actually done by the shell itself. And with brace expansions, we can actually use a range as well inside the braces. For example, so this is a range, and it is the same as typing this, but this is more convenient, of course. And so we get this result. And let's see another example with ranges. And we see that the format of so this is the start of the range and this is the end of the range. And the format of the start is preserved. So if we type 0, 1, then it is going to start 0, 1, 0, 2, 0, 3, and so on. If I just type 1, then we get 1, 2, 3, and so on. If I type, for example, 0, 0, 1, then we see that the format of the output is taken from the start of the range. So the format is preserved 001, 002, and up to 015. And the ranges can work backwards as well. For example, this is going to list all the letters of alphabet, but if I uppercase from A to Z, but if I type Z dot dot A, then it is going to list the letters of alphabet, but in the reverse direction from Z to A. And these brace expansions can also be nested inside another, like this. So we have one brace expansion here, and inside this brace expansion, we are going to paste So we have this brace expansion here and this brace expansion here, and then this enclosing one outside brace expansion. And the shell is doing this one first, and then it is doing this expansion, and it is going to replace it with the result. And then finally, it is going to apply the outer brace expansion. So this command echo first will look like this after the inner expansions. So we get A1, A2, and then A1, A2, and then we get B3, B4. This is replaced first, and then this is replaced first, and then we get a result like this. And then this base expansion is replaced, and then we will get this result. So brace expansion is also recursive. So shell expansions in general are recursive. We can nest them inside another. And let's see an example. Let's see an example of how we can use these shell expansions to do some job quickly. For example, let's say that we have some photos on a disk, which we have taken on several years, and we want to organize them according to the years and months on which these photos are taken. And so we are going to create a directory for each year and for each month for the last 3 or 4 years. Let's start by making a new directory for photos. So we create a new directory with make directory, and we created this new directory photos. Just for an example, let's go inside this directory photos, and now I will use another make dir command to create a directory for each year and each month from the year, for example, 2020 until 2025. And I can do it like this. And then minus this is the range. So this will be expanded to 4 years, and this will be expanded to 12 months. And let's see what we get as a result. So we get this 2020-01, 2020-02, 2020-03, and so on. And then 2021-01, 2021-02, and so on, up to 2024-12. So with a single command, we have created how many directories? 60 new directories. So this is going to expand to 4 or 5 to 5 items, and then this is going to expand to 12 items, and in total we will have 5 times 12, which is 60 new arguments that will be passed to the command make directory. Now Shell can also expand or replace variables. For example, if I type echo user, this $sign is going to tell the shell that the following is the name of a variable. And so the shell is going to check for this variable and will get its value from the environment, and it is going to replace it in the command line. And it is going to pass to the command echo its value. And this variable, this environment variable user actually contains the same thing as who am I. So it contains the value of the current user that is logged in into the system or into the shell. We can see a list of all the environment variables with the command print env. So print env is going to print a list of environment, and it contains all the environment variables as well. Let's try it with less. So we see that we have this shell environment. We have print working directory, which is showing the current directory, log name, home, young, and also this variable user, path, etc. Some other variables. If we type the name of a variable, if we make a mistake, for example, this variable does not exist. A variable with such name does not exist. If I try this command echo and a variable that does not exist, then shell is going to replace this with an empty value. It is not going to complain, to say, it is not going to give an error to say that such a variable does not exist. It is just going to replace it with an empty string, and so echo will just display nothing, an empty line. Now, the last shell substitution that we are going to see today is command substitution. For example, now we have this $sign and then a single parenthesis, and then inside there is a command, and then closing parenthesis. So when the shell is seeing this, it is taking this command and it is executing it, and it is going to replace this expression with the result of this command. And so the echo will get all these arguments, which are the content of the current directory, actually. Or if I say, for example, so the shell first is running this command, and it is giving this output /user /bin/ls. Then it is going to replace the result of the command here. It is going to replace this expression with the result of the command, and then it is going to run the command lsl on this result. So which ls is showing us which command is executed when we type ls on the prompt. And actually, it is going. The shell is going to execute this program /user /bin/ls. Or another example. If you remember, this command cal is going to show the calendar of the current month. And so the shell is going to run this command, and it is going to take its output, and it will place the result of the command here. So what you get, it is a little bit distorted actually, but we can use these double quotes, and then we will get the correct result. And we will see more about these double quotes and single quotes in a minute here. So we started with this command echo. And I said that this command echo is getting 4 arguments. So it is displaying these 4 arguments separated by a space. But if I actually enclose this with double quotes, now the way that the shell is interpreting this command is that it is splitting by this empty line, but actually this is being being considered as a single argument. So because of the quotes, it is going to ignore the empty lines inside this and this expression. And so this will be a single argument. And so the command echo in this case is getting just a single argument. And the argument that it is getting is this one. And it just displays this argument. So the spaces are preserved in this case. So we can use this double quotes or single quotes to preserve the spaces. If there are spaces inside an argument, then we can enclose this argument with single quotes or double quotes. And actually, double quotes also and single quotes prevent some of the expansions. So we saw some shell expansions just a few minutes ago. And some of these expansions can be prevented by using the quotes. For example, in this case, so what is happening in this case is that the shell is seeing this $1, and it is a special shell variable, and it is going to replace it with the value of $1 variable, which is empty in this case. And so the command echo does not get this. But if we enclose it with double quotes, again, we see that double quotes does not prevent the expansion of dollar of variables. Let's try to enclose it with single quotes. Now, single quotes prevent the expansion of variables inside the quote expression. So if we surround an expression with single quotes, then variables inside it will not be expanded by the shell. And another way to prevent the expansion is to use a slash in front of the dollar sign. In this case, the dollar sign will be treated as a literal character, just as a dollar sign, not indicating the start of a variable, as it usually does. So I think that the time is up for today. So we'll continue with double quotes and single quotes and how they prevent some shell expansions on the next lesson on Friday.